Today, we're going to break down the blueprint for building your first AI agents. We're talking about moving way beyond simple chatbots and into a world where AI can actually tackle complex, multi-step tasks all by itself. Sound good? Let's jump right in.
First up, we'll get on the same page about what an AI agent even is. Then we'll hit the big question: when does it actually make sense to build one? From there, we'll dive into the nuts and bolts, the core components, the difference between single and multi-agent systems, and finally, we'll cover what is probably the most critical piece of the puzzle: making them safe and reliable.
So what's all the hype with AI agents? Well, it really comes down to this massive shift. A shift from software that just automates a workflow to software that actually performs it for you. Let's really unpack what that means.
At its heart, an agent isn't just a tool you operate. Nope, it's a system that works for you. It independently gets a job done, whether that's something huge like booking a complicated trip or handling a really tricky customer service issue.
This slide really nails the difference. With regular software, you're still the one driving the car. The software just makes the car go a little faster. But with an agent, you hand over the keys. Your job changes from being the person doing the work to the person directing the work. It's a total game changer.
So how do they pull this off? Well, at the center of it all is a large language model. That's the brain. This brain can use external tools, like APIs, to actually interact with the world. And what's really cool is that it can fix its own mistakes, and it's smart enough to know when to just stop or ask a human for help, all while staying inside the safety lines we draw for it.
That all sounds pretty powerful, right? But here's the thing. Agents are not the solution for every single problem out there. So when should you actually build one? Let's run through a quick viability test.
I absolutely love this analogy because it gets right to the heart of what makes an agent so special. You see, a traditional system, that's just a checklist. But an agent, it's like a seasoned investigator. It can handle the gray areas, understand context, and connect the dots even when there's no obvious rule to follow.
So here's the first question to ask yourself. Do your workflows need nuanced judgment? Think about deciding on a customer refund. It's not always a simple yes or no. If your process is packed with these kinds of context-heavy decisions and exceptions, an agent might be exactly what you need.
Second, take a hard look at your current systems. Are they groaning under the weight of thousands of complicated, brittle rules that are a total nightmare to update? An agent's reasoning ability can often just replace that whole mess, making your system way more flexible and easier to manage.
And finally, how much of your work involves trying to make sense of unstructured data? If you're constantly digging through documents, emails, or chat logs, like say trying to understand a written insurance claim, agents have a massive, massive advantage.
Okay, so you've found the perfect problem for an agent to solve. Now what? Let's pop the hood and look at how these things are actually built. It really all comes down to three basic building blocks.
The easiest way to think about it is like this. The model is the brain, doing all the thinking and reasoning. The tools are its hands, letting it actually do things in the real world, like call an API or search a database. And the instructions? That's the rulebook, giving it crystal clear directions on how to behave.
Let's zoom in on those tools for a second, because this is where it gets really powerful. They basically fall into three buckets. You've got data tools, which let the agent find information. Then you've got action tools, which let it do things, like send an email. And then there's orchestration tools, and this is where it gets wild. This is where one agent can actually use another agent as one of its tools.
And that idea, agents calling other agents, is the perfect lead into our next topic, orchestration. How do you actually put all these pieces together into a working system? Well, you've got two main patterns to pick from.
But hang on, before we get into the different patterns, I have to share probably the single most important piece of advice in this entire guide. Start simple. Seriously, push a single agent to its absolute limits before you even consider adding the complexity of a multi-agent system. Okay, so here are the two options, side by side. A single agent system is pretty straightforward. It's one model with its set of tools just running through a task. A multi-agent system, on the other hand, splits the work up across a whole team of coordinated, specialized agents. So the first and probably most common multi-agent setup is called the manager pattern. This is perfect for big, complicated tasks that need to be broken down, but still need a single final answer. Think of it like a project manager for your AIs.
So here's how it plays out. A central manager agent gets the request from the user. It then looks at the problem and intelligently breaks it down, delegating the smaller pieces to its team of specialists, maybe a research agent or a data analysis agent. Then, when they're all done, the manager gathers up all their work and puts it together into one clean response for the user.
The second pattern is totally different. It's decentralized, which means there's no single boss. Instead, the agents all act like peers, and they hand off control to each other as needed.
This is perfect for something like customer service. Imagine a triage agent that first figures out what the customer needs. If it's a sales question, it does a complete handoff to the sales agent. And here's the key. The triage agent is now totally out of the picture. The sales agent takes over the conversation completely.
And now we've come to what is, without a doubt, the most important part of this whole blueprint: safety and reliability. An autonomous agent is worthless, or worse, it's dangerous if you can't trust it. And that's where guardrails come in.
I want you to really let this sink in, because it's the right mindset to have. You can't just look for one magic bullet for safety. Real, robust safety comes from a layered defense, where you have multiple different kinds of guardrails all working together.
So what does this layered defense look like? Well, you'll have checks on the input, like a filter to make sure the request is on topic, and another one to spot malicious prompts. Then you'll have safeguards on the agent's actions, especially for high-stakes stuff like making a payment. And of course, you always have the ultimate safety net, a clear path for a human to step in when needed.
So there you have it. We've covered the what, the when, and the how. You've got the core components, you understand the orchestration patterns, and you have a framework for safety. The blueprint is officially in your hands. So the only real question left is, what are you going to build first?